The Fourier series. The sinusoidal signals as sound are complex and hard to examine. That's why Joseph Fourier invented a decomposition. First, we'll talk about Joseph Fourier, then we'll define a periodic signal. The rest will deal more precisely with the Fourier series, and we'll finally represent what we say with an application example. Joseph Fourier was born in March the 21st, 1768 at Auxerre and died in May the 16th, 1830 at Paris, was a French physician and mathematician. He is famous for an invention which allows physicians to study easier sinusoidal signals, the Fourier series. He published it in Analytical Theory of It in 1822. A thought contested by many physicians, a lot of them still use it today. A periodic signal is one that repeats the sequence of values exactly after a fixed length of time called the period. For example, all sounds are periodic signals. Fourier found that every periodic signal can be decomposed as an infinite sum of trigonometric functions, which is called a series in math. Those functions, which their frequency is a multiple of the frequency of the original function, are called harmonics.
On the left, we can see a graphic illustration of the Fourier decomposition, and on the right, the math formula. The first term, called the amplitude, because it gives the amplitude of the final signal. The amplitude is the gap between a minimum and a maximum. Then, we add the next terms, which are cosine, with their own frequency and are preceded by coefficients which give their amplitude. We can take an example. For example, this sawtooth signal. We are going to approximate it with the Fourier series. With only the first harmonic, we get this signal. And with the first two harmonics, we get this signal. And so on for 3, 5, 10, and 50 harmonics. We finally find a signal more and more precisely until it becomes, with naked eyes, the same as the principle, even if the decomposition will never be perfect. Finally, the Fourier decomposition is a very powerful and useful tool because it simplifies enormously signal analyzations.